Hi, I'm Colin Walls, and I'm here again to talk about embedded software. Today I'm going to continue my occasional series talking about aspects of real-time operating systems. And on this occasion I want to talk about semaphores. Now, semaphores are available in almost every real-time operating system, and they come in various different forms, but broadly speaking they're used as a flagging mechanism, either to communicate and synchronize between tasks, or very commonly to control allocation and access to a particular resource. Now, semaphores come in sort of two forms. There are binary semaphores. Now, a binary semaphore is a very simple flag. It's either set or not. So if you like, it has two values, 0 and 1, hence the name binary. The other kind of semaphore is a sort of superset of a binary semaphore, which is a counting semaphore. Now, a counting semaphore has a number of different states, something more than two. It will depend from one semaphore to another how many states it has, but in the way that a binary semaphore is really just a counting semaphore with two states, a counting semaphore, I say, can have many more than that as needed. Now, the way a semaphore is used, and for the moment let's just think about a binary semaphore, is the RTOS code you will make a call to the relevant API, and what we do is obtain a semaphore. Now, obtaining a semaphore simply means setting the flag. That means that you then hold a token. You have access to the resource that the semaphore is designated to. Now, of course, you may not be able to grab the semaphore simply because somebody else has it already, in which case you will either get an error message back from the API call you've made, or your task will be suspended, waiting until the resource is available and the semaphore is available for you to obtain. Once you've got a semaphore, you then have dispossession of the resource, and at some later point, when you've finished using the resource, you need to release the semaphore so that other tasks can grab it as they need it. Now, in the case of a binary semaphore, you just have this one token and you obtain it and release it, and it just switches it on and off. With a counting semaphore, each time an obtain is successfully executed, the count goes down by 1, and when it reaches 0, anybody trying to obtain that semaphore would then get the error message or the suspension. And this might be used if you have a resource that has multiple instances. Perhaps there are 3 output ports or something like that, and you want to have exclusive use to one of them, and as they are allocated to different tasks, the semaphore will be counted down. So that's the idea of semaphores. The exact form of the APIs will vary from one RTOS to another, but the basic principles tend to survive much the same. So that's it for today. I'll be back again soon with some other topics on embedded software, and I will in future be looking at other real-time operating system features. So hope to see you again on a future occasion. Bye for now.